to liters of solutions ratio. That's why here molarity when given, you can find moles number, millimoles number, whatever you want. So here you can do like this, because it is for oxalic acid moles number given. For other one I am expressing moles number like this, 0.02 is molarity given, and V is the volume of solution you want to find in ml, and to 10 power minus 3, so that now it becomes liters. You understand the expression clearly? This is the molarity of potassium permanganate solution. V, I want to find the volume in ml of potassium permanganate solution, and this is to convert that into liters. Now it is the volume of the solution in liters, and this is the molarity. Molarity into liters, nothing but moles number, because molarity is moles per liter ratio. So now this is the moles number for oxalic acid taken in the experiment. This is the molarity of the permanganate used up, and this is the volume in ml of the solution required, and now this ratio is representing what? Moles of oxalic acid, moles only of permanganate in terms of its volume in ml per solution. So this ratio according to equation what? See, the equation says oxalic acid and permanganate react in 5:2 ratio, and therefore it is 5/2, because I took in numerator oxalic acid moles, I took 5/2. If I take permanganate in numerator, 2/5 is not a matter. So like that we can find therefore what is volume in ml and calculate. Like this, in stoichiometric calculations, depending on our requirement, it may be to find volume, it may be to find the concentration, it may be to find the percentage purity of a sample, whatever it is, we are simply basing on chemical equation. In that moles ratio, you prefer to convert the information into moles and use that mole ratio. That is the best way of approaching. If grams given or molarity given or volume asked, whatever it is, frame it to moles ratio, because that is the official relation between the substances when they are interacting. That is chemical equations information. And we can also approach by law of chemical equivalence, another official very good concept in chemistry. You understood how to find equivalent weights, so we can take that also. That is also very important, very useful one. But be sure first about equivalent weight and then proceed. Either way, you need a reaction, equation, balancing, all this. But if moles ratio known, you can go ahead with that, or by knowing the correct equivalence, you can go ahead with equivalence also. Suppose the same problem we'll handle with equivalence, just for understanding. This is one way, good. It looks finally same, but approach slightly differs. Suppose here the same reaction, same question, same numerical work, I want to handle with equivalence count. What is that? Law of chemical equivalence says that any two substances are interacting, their equivalence must be always in 1:1 ratio. That is, equivalence number of KMnO4 should be equal to equivalence number of H2C2O4. Any two whichever interacting, for them equivalence of this and equivalence of the other should be same. That is law of chemical equivalence. So you can express in equivalence and find whatever you want. For example, in this question he asked like this. So we can handle this same work by using equivalence, because that's also an official concept, according to which equivalent number of one substance must be equal to that of the other substance. Here permanganate, potassium permanganate and oxalic acid are reacting. Then equivalence of potassium permanganate and equivalence of oxalic acid should be equal. So we want to use that law of chemical equivalence. Here actually problem was what? 0.02 molar potassium permanganate solution is taken, and 0.2 moles oxalic acid is brought, and the question was to react with this 0.2 moles of oxalic acid, how many ml, I wrote V here, VML, how many ml of that permanganate required. We did it already using that moles ratio. Now same, let us express in equivalence. Here to express in equivalence, it is depending on the chemical role played. Potassium permanganate becoming MnSO4 implies it has some change in oxidation state. What is that? +7 oxidation state come down to +2 oxidation state. It means it gained 5 electrons, N factor, we used that word earlier, N factor. So potassium permanganate's N factor in this context is 5. Depending on that, when you decide its equivalence, you can say every one potassium permanganate is therefore has 5 equivalents as oxidizing agent. Similarly, for carbon here, it is in +3 oxidation state and it is becoming +4 state after producing carbon dioxide. So it is one change, one electron lost by carbon. But unlike the previous case, here 2 such carbons are there. Here 1 manganese, but here 2 carbon. So its N factor we decided earlier also as what? 1 chain, 2 carbon. That means 2 is N factor. Therefore, for every 1 mole of oxalic acid, there are 2 equivalents present. Like that, equivalence you can understand. So for this moles, 0.2 moles oxalic acid is not 0.2 moles, it is into 2 equivalents of oxalic acid, because every mole is 2 equivalents. Why 2 equivalents? Because its N factor we understand from this as 1 into 2. So that decides equivalence count. In that way, carefully, by watching the change undergone by substance, role played by substance, first you understand N factor and decide equivalence. Then you can say 1 mole has 2 equivalents there, 1 mole is having 5 equivalents here. So 0.2 moles means 0.2 into 2 equivalent. Whereas for other one, for potassium permanganate, 1 second, here I put the other one, it is potassium permanganate. So this is oxalic acid. 0.2 moles oxalic acid has into 2 number of equivalents. I converted the moles count into equivalent, that's all. Mole count became into 2 equivalents because here its N factor is 2. Like that, if you watch potassium permanganate, which I put here, potassium permanganate's N factor 5. So when you count its moles what? 0.02 into volume, in terms of to be found volume, into 10 power minus 3 mole. Moles into 5. It becomes its equivalence count. Carefully watch. Left side potassium permanganate. For that moles count already we used in the previous method. 0.02 into volume in ml into 10 power minus 3 means it is the liters volume and molarity into liters, moles number. And this moles number, this moles number is multiplied by 5, N factor. So it became now equivalence of potassium permanganate. This is equivalence of oxalic acid. So they are equal. So finally the calculation effectively the same. But viewing in mind, whether you have in mind moles or grams or equivalent, that is according to our convenience done. But preference you give to moles and next to equivalence. Whichever in a particular example convenient, you can take that and calculate. Finally, our interest to find what is this V, volume of required potassium permanganate for the reaction. So we should not get confused whether the information given in molarity, normality or weights in grams, whatever said, say one is given in moles, other is given in molarity and asking to find volume. But all these should be viewed comfortably in either mole ratio or equivalent weight ratio or equivalence ratio rather, you can easily calculate. Like this, stoichiometry must be done. And in further applications of stoichiometry, you find so many, like as we have seen, to calculate the percentage purity, how much calcium carbonate really present in a limestone sample. Like that, to analyze the sample's purities or to find the contents required for a substance to react with any other substance, like in this case, or anyway for any numerical calculation based on chemical equation, the procedure. But adopting to a simple procedure like viewing in moles,